I'm going to be teaching you how to do Lewis structures. So the first thing you want to do when you're doing Lewis structures for molecules is understand what a Lewis structure is. So a Lewis structure basically shows us how the electrons are shared and arranged around a molecule. So for instance, if we take carbon dioxide, a Lewis structure would allow us to see how oxygen and carbon are bonded and where the valence electron pairs are located around the oxygen or carbon atoms. So the first thing we want to do is find the number of valence electrons in each individual atom in our molecule. So carbon has 4, oxygen has 6, and since there's 2 of them, we have 12 for oxygen. So that gives us a total of 16 valence electrons. The next thing we want to do is arrange our different atoms in order. So in Lewis structures, the least electronegative atom comes in the middle, and in this CO2 molecule, that happens to be carbon. The next thing we want to do is use our 16 valence electrons to form bonds between the carbon and oxygen atoms. So what we know is that carbon can form either 2 double bonds or 4 single bonds. And there's only 2 other atoms, so it's probably going to be 2 double bonds. And we know this for sure because oxygen can form 2 single bonds or a double bond. So what we have here is a double bond on this side and a double bond on this side. So each one of these lines is represents 2 valence electrons. So right now we have used up 2, 4, 6, 8 valence electrons, which gives us 8 left over. We know that an oxygen atom has 6 valence electrons, and over here there's 1, and over here there's 1, so we know there's 4 left to put into this Lewis structure. So for that purpose we'll add 2 over here, and 2 over here, so there's 2 unshared pairs, and 2 over here, and 2 over here. So that is a Lewis structure for carbon dioxide. So here's another example. This is PCl3, phosphorus chloride. And the first thing, which I said before, is to count up all the number of valence electrons. So phosphorus has 5, and chlorine has 7. And there's 3 chlorine, so we multiply by 3 and we get 21. 21 plus 5 is equal to 26, so that's how many valence electrons we'll be working with. So we take our least electronegative atom, which is phosphorus, and put it in the middle around the 3 chlorine atoms. So the next thing that we do is we take our 26 valence electrons and we form the bonds. We know that phosphorus has 5 valence electrons, so it would form a maximum total of 5 bonds, but we know that chlorine only needs to form 1 bond as it has 7 valence electrons and it's looking to only gain 1 more electron. So we just connect 1 shared pair per chlorine to the phosphorus. And we have to fill out the rest of the outer shell for each chlorine, so there's 2 here, 2 here, and 2 here. So far we have used up 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26 of our valence. Sorry, let me count that again. So 6. So far we have used up 24 valence electrons. 6 and 12, 18, 20, 22, 24. We have used 24 valence electrons. So now we have 2 left. And those go to phosphorus because phosphorus has only used 1, 2, and 3 valence electrons. So we just add 2 more, 1 more unshared pair. So that's the Lewis structure for PCl3. So now I'm going to tell you a simple way of how to determine polarity of a molecule. It's usually a more complicated process, but this is just a basic way, a quick way of finding out if a molecule is polar or nonpolar. So First thing we do is look if a molecule is symmetric or not. On this carbon molecule, there is a double bond to this oxygen, and that oxygen has two unshared pairs. On the other side, there is also a double bond and two unshared pairs on this oxygen as well. So it's symmetric, so that tells us that it is nonpolar. However, for the PCl3 molecule, we can see that there is only one single bond to each of the chlorine molecules. However, there is an unshared pair on top of the phosphorus, so that tells us that this molecule is not symmetric, so it is polar. So that's just a simple way if you can determine if a molecule is nonpolar or polar. This chart shows how the Vesper theory was used to determine the geometric shape of a molecule using the shared electron pairs and the unshared electron pairs on the atoms of each atom in the molecule. So using that chart as reference, we can determine the geometric shape of this molecule. So we first look at the central atom and we see how many shared pairs there are and how many unshared pairs there are. For carbon dioxide, there are two shared pairs. The double bond is 1 and this double bond is 1. And there are no unshared pairs. So 2 shared and 0 unshared. So by looking at the chart, we find that this is linear. For the PCl3 molecule, there is 3 shared and 1 unshared. And by looking at the chart, we see that this is trigonal pyramidal. So that is an easy way to look at the shape of a molecule just by looking at the chart of the Vesper theory. Thank you.